All right, this is the first quiz. How do you tell if something's linear? Well, you do rate of change, right? This went up by 6, up by 3. That's 6 divided by 3, that's 2. And you see if that's consistent, right? So here, I'm only going up 2, but this is only going up 1. So 2 divided by 1. The other thing you could do is plot the points. If it makes a line, it's linear, right? So this one is linear, okay? So down here, I say it's linear. Linear is when you do y equals mx plus b. So I put the steps over here. You find the slope. I did that up here. It's 2. Sub in an input and output. That gives you 3 things to sub in. So you're going to sub in your rate of change, slope, input, and output. And then by doing that, you can solve for b. I picked any of these points. I decided to pick 2, 5. Just, I don't know, they're positive, nice numbers. Output is 5, input is 2, slope is 2. Do my algebra, I get b equals 1. And then you just fill in the blank to write your function. You put your rate of change, you put your x, you put your b, and that's your function. Now, how do I know if I'm right? Well, you have a boatload of input, so pick a point like 6. Let's sub it in. 2 times 6 is 12 plus 1 is 13. Yay, it gives me the right output. I could also graph it in decimals. All right, this one, do you see how it kind of goes down and then goes back up? So it's kind of like it goes down and then back up. I also plotted some of the points, right? And I'm like, oh, that looks like a parabola, right? So this is not linear. This would be quadratic. Okay, now, it's important to know the vertex here. So do you see how these repeat? 0, 3, 2, 3 repeat. They give you the same output. So there's my vertex right in between them because that's my low point, okay? If I don't give you the vertex, it can be kind of ugly to find. All right, now, this is totally different than linear because it doesn't have slope. I mean, we did secant lines, but remember with secant lines, like if I pick these 2 points, do the rate of change, it's going to be negative, and the equation of that line is going to be whatever. But if I pick 2 points here, do you see how suddenly the slope's positive for that secant line? So, I mean, the rate of change is negative and it, gets bigger and smaller. Like down here, it's pretty flat, right? And then, it's constantly changing between those 2 points. So you can't do linear stuff on this. So it has a process that might seem similar, but, other than that, it's a little bit different. So step number 1 is you put the vertex into that shell. And so remember, it's kind of y equals a x plus or minus whatever your shift is. I don't know what that is, squared, plus or minus whatever your vertical shift is, which again, I don't know what that is unless I tell you. So I know the vertex is what? 1, 2. So remember, the shifter on the x is opposite, so -1. The shifter on the y is what it says, and then squared. Okay, now the process is kind of similar. So you stick your vertex in there, and then what do? Well, you only need to sub in 2 things, okay, because you don't know A. So what you're going to do is you sub in an input and an output, and you're going to get your A, okay? So I subbed in 411, seemed like a nice friendly number, so I just grabbed it from up here, 411, subbed in my 11, okay? Subbed in my 4. Input is your X, output is your Y. Now, in algebra, this plus 2 is its own little thing. This is all glued together. So again, you can use a calculator. 3 squared is 9, the plus 2 separate. This is glued together. This is like 9 apples, and then 2 coins over here. Like they have nothing to do with each other. To get rid of adding 2, you subtract 2, divide, I got A equals 1. So then you just fill in the blank. You put your A here, your shift, which again is always opposite. Your shift there is what it is. You put an X, you put a squared, and there you go. Now, again, what do you do if you want to check your answer? Well, let's pick some random point we haven't done yet from our chart. So let's pick -1, 6. We didn't use that. So -1 is a -2, squared is 4, plus 2 is 6. Hey, guess what? It works. And you could also graph it to check it. That would be, a good idea too. All right, so if you need to pause and kind of, look at my work, go up a little bit further. You can do that. Again, the nice thing about a video is you can pause it and you can replay it over and over and over again. And you can find other videos too. So if you're like, Julie, I would rather watch this person that I found on YouTube that I think is amazing, go for it. Okay, it's all about your learning. So if this does not make sense to you, find someone or something that does. All right, I'm going to go to the back page. All right, and don't worry about this. It was worth points when I graded. Okay, so first of all, what causes 0? -2, 1. -2 it causes 0, and then your +1 there. So that's your vertex, -2, 1. That's going to be your max or your min. Okay, notice this is negative, so I know that it's going to be reflected, right? I know that. Okay, so now subbing in some points is a good idea. So I am going to sub in 0. Okay, because the y-intercept is always a nice thing to know. Sub in 0. And again, you can just type it in a calculator, -3, you know, and then I don't know where I sub my 0 in, but whatever. So I guess I didn't show the work, but 0, 2 squared is 4, -3 times 4, -12 plus 1. So again, I had to add to my graph to get that. Now, notice this is symmetrical. So that was over 1, 2 from this, my vertex. I went over 2 here. So do you get, if I count over 2 here, 1, 2, I would go down to the exact same point. Now, again, if that doesn't make sense, don't worry about it. Just sub in values and you'll figure it out. Okay. All right. So let's see. Oh, I guess I did show my work over here. Yeah, because when I subbed in 0, I got 2. So no, I did show it over here. And then this is a symmetrical one. All right, say I want another point. Say I'm like, ooh, -1. Where does that go? Sub it in. Okay, so -1 plus 2, right? Squared times -3 plus 1. But again, you do not have to do that. You can just, you know, go to Desmos and type it in. So I don't, you know, it's just so easy to make mistakes. So just, you know, don't worry about it. Let the computer do the heavy lifting for you here. Make sure you square it and then what? +1. So typing it in is half the battle. All right, see how I get a -2. So when my input is a -1, my output's a -2. So I go -1, -2. Now notice that's from here, I went done. So I'm going to go backwards 1. I know that's also going to be here at a -2. If I don't know that, what could I do? I could sub in a -3 in for the input. So you can sub in whatever points you want. Now, some of these points are going to be way off my graph. So I do kind of want to focus around here. All right, that's my graph. All right. And again, there are infinite points, by the way. So as far as domain and range, I mean, all of these are points. They're just not accurate, you know, because I'm just estimating here. But the connectivity indicates there's infinite many points. So your domain is all reals. Any x value is legal. And your range is low to high, -infinity. And make sure you include, what is my vertex, -2, 1, up to 1. And that's the one time we use y values on interval notation. Pretty much always it's x. All right, let's look at the bottom one. So let me, I don't know, kind of cover that up maybe. I'll scooch up. Maybe I'll just zoom in. I don't know what's best. All right, so this kind of goes with the other one. All right, so what's a vertex? Opposite of b over 2a? -1, remember you sub -1 into here, so -1 squared plus 2 times -1 minus 8. Type it in a calculator. Okay, I did it by hand here, but you don't have to. You get -9. Okay, so I know -1, -9 is my vertex. This thing has a positive coefficient. It is not reflected. So I know it's gonna, you know, look something like that. All right, so symmetry is x equals -1. That is an equation of a vertical line. So you do want x equals -1. All right, x-intercepts and y. Okay, so if I put the 0 in for the output, see how I'm going to get numbers for the x? Those are going to be on the x-axis. Those are called x-intercepts. So I make my output 0. This is like solving a quadratic. I just factor, set this equals 0, -4, set this equals 0, it's 2. The shifts are always opposite. So I put a dot at -4. I put a dot at 2. Okay, what else? Y-intercept. That is when if you put 0 in for x, you get a number in the y spot. That's on the y-axis. That's your y-intercept. So sub it in. get a -8. So at 0, -8. Okay. So at this point, I know this is my vertex. So there's a line of symmetry. So this guy, I would just reflect him over here. This one is what? 1, 2. I would reflect 1, 2. Okay. And then I would graph it. But again, you can always sub in extra points. You can sub in 1 input output. You could sub in -3 input output. So you don't have to do the symmetry thing. Just sub in some points over here and over here. Make sure you have accurate x-intercepts, accurate y-intercept, accurate vertex, you know what I mean? And you can get there. All right, what is a domain? Domain is left to right, all reals. There's no illegal. I can have negative, I can have 0, I can have positive, all good. Now range. This guy is the one time you use the y is on range. It can equal -9, goes off to positive infinity. Increasing. Okay, this is when you don't want to use the y. We only use the y here, never really any other time that I can think of. So here we're going down, -1 to infinity. Here, let's see, increasing from -1 to infinity. So decreasing's first, negative infinity to there, and then there. All right. Now, some of you missed this on the quiz, and I'm not exactly sure why. This looks kind of like a bunny ear type problem, right? So as x goes to positive infinity, so it's saying as your x's get bigger, what's happening to your y? It goes to positive infinity. Here, as your x goes to negative infinity. So as x goes to negative infinity, see how this is still going to positive infinity? Okay, some of you put negative infinity on there. I'm not sure. The end behavior of both of these, no matter what x is doing, these guys are both going up to positive infinity. Okay. All right. Hopefully that helps on this quiz. Again, if you're one of my students and you have questions, you can always email me. So, all right. I hope you're doing well. I will talk to you soon via email or internet or some other means. Take care. Bye-bye.